Hey everybody, good evening, welcome. I'm going to start out with a machine that's been driving me bonkers up the wall for a couple of days now. And what initially seemed like should have been a fairly straightforward current control fault. But instead, now it's become somewhat more of a nightmare. To be honest, it seems to be that's rather systematic the last few weeks in terms of what my jobs are like. So fundamentally what happens is if you plug, say, a phone to charge in and it only draws, say, 1 amp or something like that, not a problem. But if your charge current, say you've got a newer phone, say 7 or 8 or whatever, and it wants to go up to about 2 amps or something like that, it will immediately start pogoing or cycling. So what will happen is it'll get up to about 1.2, 1.3 amps, and then for whatever reason this board will shut it down and it will then restart again. Now, most of these boards use the same sort of USB power control chip, and part of that power control chip is there's a you set up a voltage divider with a couple of resistors, and it sets the current threshold that you safety disconnect. But it's not that. It's not that that's triggering. So it's driving me up the wall, and I'm at the point now where I'm considering actually removing the connector. Particularly after last night's fiasco, I'm sort of thinking maybe it's a problem in the connector. Maybe there's a bimetallic situation where there's a bit of corrosion, and when the current gets above, say, 1.2 amps or something like that, it actually causes that contact or something in there to heat up and curl away. And then as soon as the current's gone, it comes back, and so on and so forth. I just don't know. I'm sort of like grasping at straws here. So, yeah. Anyway, I'll have a hey, Riston UK, Travis, Steve, Christian, Steve. Wait, it said Steve already. I'll have another look at the circuitry and see if I can work out what the heck's going on. And according to the data sheet for the particular chip, Apple basically just copies it straight out of the book. And so I can't really find a fault there. Loving the thick hedge of the beard. Yes, it's called laziness. Probably not to the degree, because it'll be, if there is a fault in the connector, it's going to be too shielded in. It's going to be somewhere in here. It may be in the contacts, I don't know. Perhaps the first thing I can try is to actually take this shield off and reapply the solder, and see if what is that? Reapply the solder and see if that fixes the problem. What's this grasp? Grasp what? Hello, Eddie. Hey, Solder Bridge. It's Barry West time there. But I have basically, I just noticed my dial has been turned off there. Anyway, basically I have replaced essentially everything here to no avail. This is the controller. These here are both 40, I think 44K, I can't remember. Anyway, they are set together, they're 22.1K, that's right, 22.1K, to threshold at 2.5 amps. Is this the one bent pins? No, we've done the bent pin thing. That's done. It's already paid for and heading on its way back to the customer. So yeah, oh, grasping straws, right? Thank you. Yes. Thank you very much. Thank you very much. I mean, I even went along and changed these values so I could set the current trip threshold to be substantially higher, but it didn't change a thing. So that's why I'm thinking it's really not likely to be the circuitry. Yeah, so yeah, first thing we'll do, we'll try to take this shield off, and then we will try and resolder those pin connections. Mind you, I sort of am disinclined to take that route on the basis of the fact that it may fix it temporarily, but chances are the fault may still reside in there, and it will just come back out later. So perhaps I should actually just go the whole hog, take the connector out, and get it done with. So the first thing I should really do is source a connector, and doing that we can have some practice. Now, the big problem with dealing with any of these connectors on these boards, of course, is that as you try to work on one, you invariably melt the others. And this, of course, naturally is in the middle, so it's going to try and take out both its partners. So we're going to have to try very hard not to mess that up. As you can see, I'm already struggling enough as it is with just keeping the microphone connector under control. Fun and games. Alright, we'll get another one of these boards and we'll try to take the USB connector off it. This board in particular has me sort of very apprehensive because it's actually it's a very clean board, this one. Very clean board. Oh man, all these connectors are so butchered. Does Captain tell? Not a lot, not as much as what people would think. The main trick is to try and just keep the air off it. You can, let's see, if you can maintain the air gap between the hot air that's actually been blown and the plastic, you usually do okay. The problem occurs as soon as the air touches the plastic or blows across it. It can actually sit in a fairly hot oven-like environment. I mean, obviously they reflow these, but yeah, as soon as you start blowing, hitting it with hot air, the points create hot spots, and that causes a problem. So we'll try and get this one off as a practice. Miles. Yeah, this is a particularly nice machine. This machine is downright near perfect in terms of it's freshly out of a box. So to mar it up with my butchery is going to be painful even for me. Two different job descriptions, 547, 569. What? No, this is 569 is correct. Did I? No, I'll have to come back and change that description later, the other one. Okay, I'm just trying to experiment. I may even have to create like a special shield thing, like cut out a piece here so that I can protect that area. Maybe I'll try that. It's not like I've got a shortage of these tin sheet metal things. $547 on screen. Oh, right, I see what you're saying. Oh, right. There we go. These snips do not work beyond a certain depth very well. I don't like it when you have to squeeze them down so that you pinch the tip. Because when you pinch the tip on snips, it deforms the metal in a way that you can't get that damage out. But if you can move the snips forward before you get right to the tip, then it's okay. That's pretty much entry-level metalwork class. Nope, can't put that one there. Okay. Oh, that's right, I've got to let Jim know. He'll be upset with me now. Where are you, Jim? Streaming. is going to be like I was asleep, damn it. Why'd you wake me up for? Hey, Walter. Yeah, this is going to be fun. So much fun. This is where you really can do with a universal jointed or multi-joint holder for this sort of stuff. So you can just put the hot air in position and let it do its work rather than having to manually hold it, because you know you're going to get impatient if you're holding it. It's inevitable. Because if you could do this sort of thing without doing any damage, but it takes you 5 or 6 minutes to do it, you know you're going to get impatient. I've got the airflow rate right down. Just trying to see what I can get away with. Oh. Alright, so we did that first section pretty... Oh, something just fell off the workbench. Hey Jim. Alright Jim, we haven't gotten too far in, so you haven't missed out on much. But my apologies for not getting to you quicker. I'm just going to drop some leaded into these points. Damn, why do they have to have so many? Alright. Just realised we're a little bit off camera there. What I'll also do in order to try and help the situation is plug in a USB piece of metal. That said, it might also act more as a heat sink, I'm not sure, we'll see. Ideally, this sucker should just drop right out. Just trying. There it goes. Come on. Well, apart from the black tips on it, that's a pretty good extraction in my opinion. I'm quite happy with that. Hey Jurgen. Now the question is, how much damage do I do? Okay, the audio port survived, and the Thunderbolt seems to be okay too. The only thing we sort of are losing here is the microphone connector, and we can kind of resurrect that because we can just rip these out like that and put a new one in. Okay, so that was with our donor board. So we've now got our connector. Now the stakes come up somewhat as I work on the actual unit. The story with the port is that anything over 1.2 amps causes it to cycle. And now you're immediately going to say, well, that's probably the current threshold thingamajig. And unfortunately it's not. Unfortunately it's very much not that. I wish it was, but it is not. All that circuitry has been replaced outright. Jacob, the days are pretty busy at the moment because in about 36 hours this house will be completely, well, it'll be all mine. All the rooms, everything. Well, okay, well, mine and Alita's. When I say mine, I mean, yeah, you just got to assume Alita actually has superior ownership involvement here. Okay, so this is going to get butchered up, but not much we can do. It's a sacrifice we have to make. And we can always replace it later. Now we don't have to care if we do damage this connector much, but I'm just trying to avoid damaging the audio jack on the other side and this, damn it, Thunderbolt ports. I mean, I have actually owned the house for several months. That's okay. That's it. We kind of butchered that up a bit. We'll definitely have to replace it now. God damn it. Okay, we got a problem. For some reason I wasn't able to grasp this one like I was the other one. And I'm melting something, damn it. Something's going wrong. Best we find out before we get too pushy. Alright, okay. got itself jammed in there for some reason. Try not waste any time. We'll capitalise on the fact that the board is heated. Once again, going to just pop some leaded solder down those holes. It may or may not help, I'm not sure. It may make my life harder later. Again, not sure. Okay, there we go. Of course, the other fun thing about this whole process is that I obviously have to clear out all those holes, and that's usually quite a bit of fun indeed. Yeah, pretty much as I expected. Alright, we're gonna have to have some fun here. Oh, Walter White, that's a terrible, terrible joke. Yeah, I can use a chunkier tip, but right now I'm just seeing if I can get away with just using the hot air wick out technique. First I had to get all the surface layer stuff out, so then I can work on the not so surface layer stuff. shove it back, do it again. Yeah, Walter, I know the fan connector's butchered. I mentioned it before. I said I'm just going to replace it. It was a required sacrifice, as it were. Getting a little bit tricky getting some of those out. Just got to keep persistent with it. It's more effective in my opinion than using the fat iron tips. And you definitely have to keep the wick soaked with flux, or else it tends to just very quickly lose its effectiveness. Yeah, solder sucky thingies don't work so well at this scale, unfortunately. I do have them, but they just don't work very well at this scale. They pretty much are limited to pin-through type stuff. Hey, Mr. Lemon. I think we've got one hole, just that one there, that's problematic. Yeah, I know the electric ones, yeah. But I still find that, yeah, they just don't have the precision drawing power at such small scales as this. I mean, these are exceptionally tiny holes, really. Right, I think we're clear. was the dud one. I was about to say, man, that looks really bad. They're jamming some sort of probe through when it's molten is always a good trick. The middle pin is... the one in the middle there needs to come forward slightly. Hey Mark, how's it going? Seems like everybody's obsessed with the plungers. I'll make it clear, I don't believe they have any real functional ability at this scale. Ah, scratchy, scratchy nose. I'm doing a bad job of this. I haven't got anything to hold the part in place properly. So I sort of need to line it up, and then, so I've got 2 tacks in it. And after all this, you just know this is going to still not work properly. Hey Saver Specialist, welcome. Okay, so at this point now I can switch to just assistive air, as in 200, 250 centigrade. So it's not going to melt the plastic, or it shouldn't. I'll be in big trouble if it does. But it will help get the solder down. Yeah, I'm not sure if that actually has gone down. need some more flux. Once I've got a few in, oh great, of all of them I picked the ground ones, yeah. That'll explain why they're not going anywhere in a hurry. Yeah, they may just have to wait till later. And if you think this is fun, you should try it on things like the A1398 USB-C socket plug. That thing is a major pain. If you're not sure what I'm talking about, basically with the things like the 1706, 1707s, you know, most modern USB-C type MacBooks, they have a separate cable that has the USB ports on it. I'm running out of flux too quickly on this. But with the 1708, they just solder the port straight to the main board. And it really makes it a pain, because many a time people do mash up those ports, or they get corroded, or yeah, stuff happens. And so you have to pull the whole damn thing out. Anyway. Now I can see it drawing it down there, so that's what I want. There we go. See how it just sucked that right down? That's the effect you want. That's when you know you've managed to get it to drop down onto the pin. I mean, it's not the worst change in the 1708, but it's certainly not fun. Kind of able to cheat with these ones because the board's already warmed up now. Yeah, you can see when it happens, it just like pops. Okay. This one I think will be a dud. Okay, and I'm just going to go, now that there's solder in the holes, I'm going to go back with the assistive heat, hit them with the soldering iron tip again, and see if they drop in anymore. And then we pretty much call it. That one finally dropped in. There it goes, that one went too. Yeah, you could do the solder paste trick, I suppose. I guess I worry about voids when doing the solder paste, but you're right, that would work. Alright, that is seriously shonky, which I can see why they put a cover on the... let's see. Just need to turn a resistor around here. Not a resistor, this diode. It's only a protection diode, but I do need to turn it around. Now, being leaded solder, hopefully it will work with me a little quicker. Oh, son of a gun. No panic. It's not a big issue. They are just over voltage protection diodes. It looks like we managed to take out that one too. So we've got 3 of them to put back. Over Chumbawelby. Well, at this point what I'll do is I'll actually test it, see if it misbehaves. And if it doesn't misbehave, we'll put the protection diodes back on. I gotta admit, I'm actually pretty happy with how that's worked out. Yeah, there's no real melting or burning or anything like that, so that's good. Screaming or crying. Yeah, you can see how the solder has, for the most part, come up and wicked in onto those legs, those chassis legs, so that's a good sign. That's what you want to see. You can see the factory is pretty much the same, just with a little more corrosion and a little less flux. Alright. Now, fortunately, to test this, I need to put it back into a chassis. I guess I will put it back into this particular chassis. The reason being is because I need 2 USB ports. I need one to boot the system, and then I need to use this one here to test the current. It's also half of the reason why it drives me insane working on this one. Is this who's giving me what for a run for money? No, Lewis is a specialist in spherical things. Paul now wonders where... Ah, there it is. I was wondering where I put the chassis. It's all good. Found it. Yeah, the fan connector was deliberately sacrificed because all I really have to do with that fan connector is actually just rip off the lock bar and insert a new lock bar. Electrically, it's perfectly fine otherwise. Or at least it's a pretty good chance it should be. And worst case scenario, if it's not, then we'll just replace that. But there was no realistic way, at least in my opinion, I didn't feel I had a realistic way of replacing that USB port and protecting the fan connector without creating a situation which would likely result in me unduly risking the quality of the removal or the installation, because I'd be like, oh no, the fan connector, or yeah, there'd be a piece of metal in my way or something like that. Whereas at least this way I was like, okay, we're going to sacrifice that fan connector, and that lets us focus on the USB connector, and we don't have to worry about scratching our nose, don't have to worry about things like that. So it was a willing strategic choice. I mean, yeah, maybe some people out there will happily be able to do all that and save the fan connector all in one hit, and bravo to them. And there's people out there who can swap iPhone 6 CPUs. Yeah, that's quite a technical feat. But I've decided this time I'm not going to go that crazy or that talented. I hate it how these keyboard connectors have this notorious habit of rolling up in that corner. Okay. Hey Daniel. Oh, Joseph, every day I wake up, have a look at my stats and see where I am. I mean, I own a reasonable amount because of the fact that I had a 20% deposit right from the start, so that was a big help. Yeah, no battery. I think the only way that CPU replacements on iPhones are viable is because when they're dealing with data recovery situations. So if a person desperately needs their data, they're probably going to pay $1,500 or so for it. And that way, what you do is you take it for $1,500, you then contact someone over in China or whatever who does it for 50, you give them 50, and you pocket the 1,450 for yourself. Okay, what the hell just happened here? Did that just blank out? Did I knock something then? Oh, maybe this is one that needs the battery to boot. I hate these ones. Yeah. Welcome to a rabbit hole that isn't actually a rabbit hole. If you don't have the battery in there and it's not connected, it just does that. It gets to like 3/4 of the boot and then just dies. It's alarming at first, and then you realise it's a load of crap. See, Joseph King had 5% deposit on ours 20 years ago, so the game wasn't much fun for the first 18 months. Yeah. What interest rate were you running at back then? Because I've got 140 left to pay. I've obviously already put 40 down, and then I'm on about a 2.6% interest. I think my weekly is supposed to be about $180, but I pay about $300 a week. But I am capped at putting in 20,000 a year. That's fine. I'll put in the 20,000. It should be good. Alright, I don't even really have to log in for this to work. Unfortunately, you're not really going to see if it works or not. At least not on the current meter. So I'll plug it in. And even I don't get to see the current meter because it's pointed the wrong way. Okay, so we're showing 0. What you will know, my sync is out? Seriously? Yeah. Anyway, let's get to the point. If this goes bong, 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 then it's not working. That's not even charging. Okay, we're charging at 400 and something, which is actually low. But I think when these devices, when you have an active device charging, like an iPhone, into a laptop, I think that while the phone is completely dead and you plug it into a laptop, the laptop will only give you that half amp. It's different when you're using a dedicated charger, because the dedicated charger is not going to go through the negotiations or limit you. It's just going to say, yeah, sure, you want everything, here you go. So hopefully this will come up soon. Jürgen, the macOS test is something that I just created. It's just a High Sierra install, and then I just loaded it with programs that I used, like the keyboard tester, the Valley graphics tester, and now that's pretty much, oh, and the hardware sensors, HW sensors or whatever it is, to give you all the temperatures. That's really it. Everything else is just normal Mac things like volume test, brightness test, all that sort of thing. So the only unique programs are Valley, the keyboard tester, and damn it, what was the other one again? Oh, and the hardware sensors. Yeah, it's maxing out at 500 until it wakes up. As soon as this phone wakes up, it will want 2 amps or so. So we're waiting on that. And unfortunately, I neglect this iPhone XR. It's a perfectly good phone. There's, it works, everything's right with it. It's mine, but I just never use it. But I'm not giving it up either, because it's a good test phone. Well, at least it is coming up saying it wants to be charged. I'm just going to have to wait it out. Usually it doesn't take more than about 5 minutes at half amp before it's got enough juice to get running. Usually. Yeah, famous last words. Try to switch on the iPhone. Well, plugging it in and out usually does it. Tony, I don't know, I've never tried hardware sensors on the more recent versions. I just pick High Sierra because it's a version of macOS that seems to work well without being too problematic. Oh, by the way, the issues I was having with the CD3215s, I don't know, some of you are aware of it, but I've ordered a batch of them, and it seems like they're probably BO3s that have been repainted and re-laser cut for the etching of the writing. Anyway, the supplier has agreed to send me another batch of them from a different source. Yeah, it was, I wouldn't say fairly obvious, but there was definitely something sus about them because the laser etching was very shallow, whereas the originals, it's quite a deep etch, burn through. And if you looked at the edge of the chip, you could see that someone had actually painted over the edges. It is charging, but only if you press the button. Yeah, see there, see, or is that? Wait, yeah, it's drawing 500 milliamp. It's still drawing 500. Well, this particular supplier I've been using for quite a few years now, and I've bought a lot of stuff through them. So, and the fact that I had photo sort of indications that something was dodgy, they sort of went, oh, okay. Okay, what I might do is just plug this into the dedicated charger until it comes up to boot sort of speed, because it seems like it's going to take a little while. Yeah, see, on the dedicated charger, it's drawing 2.2 amps. So that's almost 5 times faster than waiting for the MacBook. I did used to have some USB port load testers. So basically all it was actually, where are they? While we're waiting. Essentially all they are is a USB plug with a bunch of resistors on it. Pardon me. Mind you, because there's no protocol negotiation, when it comes to being plugged into the PC, again, we're limited to half an amp. No, the phone isn't broke. Please don't. Please, please don't jinx my phone. I do like the XR, but I do have the 7 Plus, so for my daily driver, I prefer to have the 7 Plus. What did you do with the 1707 that didn't go to the 20 volt? Oh, that one, it ended up being a broken resistor, pull-up resistor on SMC Reset L. And that's all it was. And the resistor was intermittently broken. Okay, we're booting up now. There, it was just that one itty-bitty resistor. And what was scary is that it was nowhere near the original corrosion. Alright, here we go. Let's see if we go boonk, boonk, boonk. No, we're still boonking. See? So it wasn't the port. Bloody hell, what is the fault here? Hey Zentex, been a long time since I've seen you. And let me show you what it's doing on the port. Yeah. Sorry. The reason why the current value jumps around a bit is it's an aliasing sampling issue. But you get the idea. So it's trying to pick out to 2 amps and stuff like that, and it just shuts the port down and resets it. So that's what's happening. Well, so much for the port being the fault. At least we eliminated that option. And it only happens on that one port, yes. Well, actually, I'm going to double check that. But from what I remember when I was doing the testing, yeah, it's only on the main board port. It is not on the daughter board port. No, it wouldn't be the current sense parts left off because they are just, well, you know, it might be, but normally the only time those parts come into play is if you have an over voltage on the line. And they would, more than anything, they would actually tend to make the port misbehave if they're faulty. But since we removed them, they're not even involved at all. Jimbo, maybe. I'm not sure. The trouble for Chumbawamba is that aside from the... I'll bring up the schematic just now, but aside from the switch that allows the power to go through and has its own built-in current limiter, there isn't any current detection going on that I'm aware of on this board. And I've already replaced all of that circuitry, including the resistors that set the current. Walter, yeah, I mean, what else are you going to do? Give up? Not likely. At least we know it's not the port now. That said, you know, it could actually be sort of like a trace from the port. I don't know. It could be an internal board trace, but... And it's cycling too quick for it to be a polyfuse. Or at least I think it is. Ach, niemand, what's going on here? This is taking too long to boot. Barry, I'm not sure what you mean. It's like, this is the behavior of this particular model. These models do that. If you don't have the battery connected, they'll just... That's the way they behave. Is that progressing or is it just... Yeah, it is, yeah. It's just... Oh, it's probably getting slow because it's overheating now. I think it's... No, it's a perfectly good battery. The battery passes all the tests. Anyway, let's plug this in and see if it goes boom, 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 boom. And as you can see, it does... Oh, it does now. Oh, we have a breakthrough. Okay, this is happening on both ports now. Alright. That is a breakthrough. Before it was definitely only on the one port. And I just completely jacked up my USB stick. Alright, now that it's both ports, that completely changes the fault finding. It sounds like a CPU OC Bizarro faulty. And being both ports, I'm now going to suspect PP bus 5VS4 I think 5ES4 might not be able to deliver the power. Let's see. Schematic for flip cycle. Stat. 426, which is really a 163. Okay, schematic. Okay, so if we have a look at this, just go straight to the here. Now both the switches are powered by 5ES4. Now 5ES4 is a fairly decent sort of size beast, and it's this U7501 that generates it. So there could be a problem in the generation here. It could be, I don't know, bad inductor, bad caps, bad driver, bad feedback. There's a lot of possible things. Miles, I will kick you right in the delicates with that sort of attitude. You can save that attitude for when it really is going to be that, okay? I don't want that right now. This is a money-making job. And my name is not Lewis Rossman, so therefore I do not roll around in a great water tower of richness. Instead I dawdle in a puddle of scum. I'm not even going to probe that line. I'm just going to pull the board out, have a look at that chip assembly area, check the diode modes, and compare. Mind you, if I'm not careful and I do probe it, it'll probably just shut down my whole system instead. I'll probably say, sorry Paul, I can't allow you to probe that. Yeah. Then again, I'm used to hearing that. Oh, bravo! My XR just fell off the bench. Well done. I'll measure stuff, but quite often, damn it, quite often it's quicker to simply have a look at the board. So we're going to look at this area here. Well, there's a couple of slightly browned up resistors there. Yeah, the Australian dollar exchange rate. My goodness, it's horrible right now. It's just kind of a little bit strange, though, that it's interesting it feeds back into itself. Yep. It's a little bit strange, though, how strong the Australian dollar is persisting for it. Rather rude of it. Pardon me. Now, the only thing that does make me kind of ponder a bit is why aren't other things being affected, or is 5ES4 almost exclusively just for USB? Yeah, see, it feeds... No, you can't see. It feeds 5ES3, which, mind you, is only 0.3 amps that it wants out of that. Oh, yeah, thanks for it, Mel. I just realised I've got to finish that. I've worked out what my secret key combos were, so I can now do what I was intending to do. Okay, most of the Sorry, I'm sort of like stopping and starting here, and I realise that is somewhat irritating for some people. Okay, this is where the schematics and the board view differ. This is probably going to go back to the other style of board. We'll do the all-in. I'll demonstrate what I mean. So we've got this notch here, which is here, and we've got this colossal coil, which is right in the view there, and we've got that cap, and we've got the three little caps there. Actually, you know, ignore me. I was just misreading it. So when you look at the size of that coil, yeah, that's a hefty rail. So you wouldn't really think 2 amps would make it tumble down. So what are we missing? Is there corrosion somewhere that we can't see? I don't believe that's corrosion. That's part of the resistor assembly. That looks green there. I wouldn't say there's a cap missing there. It's probably just a no stuff. Yeah, see, no stuff. So if we look here, we've got V out. I don't know if you can read that. Anyway, V out 5 volts, 11 amps max. So us asking for another 2 amps, something's a little whack here. I'm going to check the current sense values. See if they're out of whack. Around the first... What'd you say, Barry? Because there was this one here, but that's not missing, that's just factory. This one here, they're just factory no stuffs. Factory no stuff. That resistor there does sort of shine out a little weirdly to me. Is that 8141? 342 G3 hot. That is not even involved in it. And you start getting paranoid. You're like, is that a burn mark, or is that just normal laser etch? Because remember, these resistors are trimmed using laser. 5VS full power, good. So that should be 470k. As long as it reads lower than that. Here we go, we're using the meter. These sociopaths demanding I do such things. Smack on 470. Can't. Yeah, there's just a bit of junk on it. Let's have a look at that chip on the edge. What's interesting is that it recovers very immediately. So it doesn't cause a full shutdown. That's a perfectly pretty chip there. Disinclined to blame that for anything. Now, I'm not sure how, if I say have a very reduced capacitance on that line, on that output, I'm not sure how the ripple would affect the ability for it to maintain regulation. Because we do have a couple of tantalums on here, aka tantrum caps. I was thinking if one of them's gone down like a see, I don't want to just start ripping up stuff. That's when things start going bad, you know. Like, well, pulling out that socket is a perfectly good example. Thank goodness we didn't butcher it too bad. You know, we ended up, sure, we damaged the fan connector, but that aside, we managed to maintain our dignity. I've got no reason to think anything else is unstable. That's the thing, it just seems exclusive to 5ES4. Yeah, I'll have to start tracing back. The reason why I'm rather reluctant to do that many a time is simply because of the fact that, you know, it's a lot of rigging up to do these things, and you can easily botch up your measurement thing. I wonder if there's a fault on that connector, J95. Yeah, a bit of corrosion on here or something. We have had it before, remember? In this case, it looks like it's okay. Yeah, I'm trying to think, what if there's something preloading the current demand? That's Q8050. Oh, that's 5ES3, that doesn't count. Q8060. 5ESO. Yeah, it's strange that 5ESO doesn't get hit, because we don't see anything else happen to the machine. The fans don't glitch, nothing, so... It's very strange. Because if anything happens to 5ES4, you would expect it to happen to 5ESO, and if you lost 5ESO for even a smidge of a bit of time, you would know. Yeah, you would know that it's flickering or something like that. Which kind of leaves PM Sleep S4L as a possible candidate. Alright, we'll see if we can use PM Sleep S4L. We'll trace that and see if it misbehaves. Yay. What a pain in the butt. This isn't. Yeah, this isn't going to be easy to do. Hey Greg, welcome. Have you tried different cable? Yes, tried. Well, see, the thing is, the customer complained about it, and this is my own cable, and it's doing it. So it kind of stands to reason that the fault is definitely not the cable. Solderbridge, no, we were waiting for you to provide us sage advice and stop us running around like little idiots. Without you here, we can't do anything constructive. We're all just useless sacks of protoplasm. On the upside, we have determined that it is actually affecting both ports, it's not just the one anymore. Because Solder Bridge thinks that it's cool to be defiant and stir up social drama. That's the way that people feel that they've attained value in society, a place in society. And it's sort of the easier way of doing it. Do something controversial. Now he's going to have a rant at me and he said, that's a lot of crap. To be fair, solder is spelt without the L in far too many places, to the point where it is becoming a acceptable alternative. And I find that upsetting. And nobody cares. The reason why I'm just casually browsing around the rest of the board is because now that we have determined that it happens on both ports, then the fault could be located pretty much anywhere. But the fact that it comes about after about 1.5 sort of amps, it does feel like that it could be current sent. Ooh, wonder if. Ooh, yeah. Well, I was heading back. Again, the problem is that if we lost 5 VSO, we would really notice it, but we don't. What's common on the voltage rail of both ports? Well, like I said, that's basically PP5VS4 is the common factor, and PM sleep S4L. I wonder if that goes to. Yeah, it goes there as well. Okay. Reball the SMC. That will not be happening right away. Tempting, but no. Oh look, we've got a fake person in the chat. Alright, what I'm going to do is I'm going to just power it up like this, and then I'm fairly sure it won't do it but until it gets into the OS. But we'll see if it does do the hiccup. But I'm fairly sure it doesn't do it until it's into the OS. Now, unfortunately, I have looked with the infrared camera and I have not spotted anything in the past. So unfortunately, that one's already been done and dusted and found not to provide any information. I wish it did. It would have been easier. Naturally, I'll plug this in upside down. It's not doing it at the moment, and I can guarantee you that's probably because it's sitting at 500. Yep, 477. So yeah, unless there's an OS present, it won't switch up to the higher current. Let's see. Okay, so this is a USB 3 port. Do I have a USB 3 hub that I can use? I've got one, but my camera is attached to it. Ah, that's not happening. Well, I think, Warren, the problem is that until it gets to the OS, it's not going to do the USB driver negotiate. Yeah, it's not going to actually talk to the USB device and say, oh, you want to negotiate up to a higher current. So that's why that's not happening. GTG. Pardon me. Not for this model, I don't know. I'll tell you what though, I'll get another one of these, another daughter board. That's what I'll have. Or easier yet, I'll just take this one out, I think. Yeah. I'll just take this daughter board out. And then we can use it. At the start, I had hoped that it was. Oh, wonder now. Because I thought it was a one-port fault, or at least originally it seemed to be. I didn't bother looking carefully at the daughter board, but it's entirely possible that the fault lies on the daughter board. Oh, daughter board, because the fault, maybe, I don't know. Daughter boards are notorious for being problematic. And we'll probably find there's absolutely nothing wrong with this one. Yeah, typical. Pretty much clean as a whistle for all intents and purposes. I was sort of thinking maybe the daughter board was the damage maker. but I honestly can't see anything on here that I could lay blame to. Damn it. Why are all my good options being taken from me? It's like it doesn't love me anymore. Could it be the cross-member flex? That's another possibility. You know, it's going to suck if it's this flex, because that would mean that's quite a bit of work that was done for no good point. But to be honest, this flex looks super clean. I said this whole machine is so clean. In saying that, it probably wouldn't hurt for me to try a different flex and dock daughter board. Yeah, I'd say we should just try that. Oh, ow! Ooh, that was painful. Well, I wasn't so much thinking that the USB port explicitly would be causing the fault, but maybe there was a problem with the 5VS4 line input over here. But it still does present the issue of if that maybe it's a case I feel like I'm going around in circles here and the fault is laughing at me, and it's an obvious fault somewhere and I'm just missing the point somewhere. So now when these go over current, they send this USB overcurrent fault, pulls the line down and alerts the CPU that there's an overcurrent condition, at which point the CPU, how does the CPU respond in that case? Because usually with this particular chip you often have a cap on this line and it creates a delay for when it brings itself back up. Try it without that board. The trouble is I just can't, because I've actually haven't got a USB hub 3. Or maybe I do. I'll try. I've got one downstairs, but I don't know if it's going to be Mac compatible. But I'll give it a shot. I'll be back in a minute. Well, it seems I cannot find that hub. It may be a case of I threw this hub out in a fit of extreme disgust at just simply how utterly incompetent it was in doing its job as a hub. It spent more time just simply causing dramas on the bus. Like an angry school kid that had a bad upbringing and decides to become a bully and stealing kids' lunch money and bags. Damn, that is annoying. So annoying. I'm not even sure what camera we're going to lose when I do this, but see how we go. Sayonara. We're on overhead only, so this better work, else we basically upset the entire system for nothing. So we'll put our Mac boot in. We got audio back. Well, this is why you do not mess with your AV setup in the middle of a stream. 5x5, right. This will take a little while. Well, let's throw a chipmunk in while we're at it. Ooh, okay. Here we go. Chipmunk actually saves the day. Have a look. This is why the chipmunk is better than other devices. You notice what's missing on that? I'm sure you can. I'm going to wait for people to see what's missing. See what happens when I pull this out. Yep. 5 volt. Our 5 volt is not a good 5 volt. That is the problem here. So the chipmunk is basically saying, you're alive, buddy, but you could do with a little more life. So this is the new chipmunk. It's not the ideal I'm missing. What it is that it checks against a reference to see how good that 5 volt is. And if it's not up to a certain level, then it will not light that light up. Okay, so now what I'm going to do is see where 5ES4 is that I can get my hands on. Okay, that cap there. Let me guess, my multimeter's out of action? No, it's not. Let's see what our 5 volt line is. Well, according to this, it's 5.03. Interesting. I need to put my glasses on. And I wish I had another port to use here. It could also be that the USB port is actually causing the problem here. Where are my glasses? Are they on my chest? No. Yeah, I added the lug. Yeah. I've got enough chipmunks that I can afford to do ridiculous things like that. 5.02 again. Okay, which one of these damn pins is 5 volts? Okay, so that's reading 4.6 there, so maybe it is actually the fault of the hub. Okay, what about the inductor? 4605. What's going on there? 502. 502. I have a feeling that this is actually a red herring. I have a feeling that it's actually the hub at fault. Yep, it's the hub at fault. Damn it. It's kind of crazy that the hub would lose that much voltage. That's a piece of junk that goes in the bin. Yeah, well. It's a selectively powered hub. Now what am I going to do? Stick the USB meter between the hub and the board. No. I suppose we can try that. But still, like I said, I mean, 0.4 or was it 0.6 volt drop? That's really pushing it. That's some awful quality in there in that case. Makes me want to rip it open and find out just why it's so atrociously bad. There is this here, which you're probably supposed to put 5 volts in via. I always find it interesting that they use USB to power USB. Holy oh, terrible design. Wait, that's racist. Well, anyway, terrible design. Just bad soldering, really. Okay, we are probably not gonna. Yeah, try to reset the camera and maybe we get lucky. Come on, come on, come on, give it to me. Yes. Alright, so anyone want to know why this hub wasn't working so well? Oh, yeah. Oh, look, we've got a free bug. Yeah, the bug doesn't want to come out. Alright, so this is pretty much the level of soldering I expect. That is some amazing crap. Jeez, that's bad. And I've got to work out how to get onto the other side. because this grommet has locked the cable in. And I can guarantee you it's going to be just as bad on the other side. And I've got to work out how to get around this grommet lock. Oh, I know what they've done. Okay, I understand now how they've created this. Now the trick is for me to uncreate it. Gotcha. Yeah. Okay, orange went on there, just so we all know. I gotta jam this back in somehow. It's purple coming off too? Jeez. So we've got it over the threshold, that's good. There we go. Alright. Poop. Okay, I'm pretty sure that was purple and then orange. I really, really want to redo all of it, but there's not enough movement there. I think I might just knock off this grommet. I mean, it's about the only thing doing its job right, but I want to get more cable length here, so I'm going to have to sacrifice the grommet. Hot glue will fix that up later anyway. Okay. Hey, 10-minute text here. G'day, mate. Yeah. Okay, so what I think we should do is just basically get rid of everything here. Now, I know this probably amazingly probably does follow conventions, but I still need to write it down anyway. Okay. So we've got, whoops, sorry folks. So we've got black, green, white, red. And then we flip over, orange, purple, ground, right. Orange, purple, braid, yellow, blue. So what we're going to do is just desolder all of this and do it properly. And at least tonight I'll feel like I've actually done something. It's harder for me to rewind the tape than for you guys. I think half the problem here is the unrealistic amount of room that is given to fit all these cables in. It's like they give you 3mm, and it's not enough. If you want to do a decent cabling, you've got to have some sort of flex area, relief area. And I've noticed that pretty much for all eternity, relief area when it comes to cabling is it's just not something that's done very often. Yeah, there's still too much lead free in that. Orange is on the outside, yeah, I've got that, yep. Now, while we're here, we may as well have a look at what else we're contending with. Well, at least they actually soldered in the mechanical mounts. I've got some other ones where they don't even bother soldering in those mechanical mounts. And they've actually got branded controller chips, that's quite something. Again, usually they just scrub the brands off, So I mean, overall it's not a terrible product, it's just been finished terribly. So we're going to give ourselves the luxury of a lot of cable room on this, and as I commit cables in and start cutting with a pair of side cutters into the sheath, great sin. Om nom nom. Hey King Serious, thank you. Admin Media, can I link in chat to PC Part Picker that reinstall what? Maybe you have to spell it out. I think the problem is that only mods can put up links at the moment. I'm trying not to cut through the shield, and it looks like I was successful in not cutting through the shield, but come to think of it, I probably should have. Alright, so these double shielded ones are USB 3, and this is your standard Italian USB. I said Italian because I'm trying to think of a flag that has most of those colours. Yeah, I was thinking of getting the proper wire strippers, but we'll try the old dirty style. Shoot. Okay, judicious cable required here. What is going on? This white cable feels quite a bit weaker. My side cutters are just too, they're clearly not sharp enough. That's okay, we've got plenty of cable. And if we butcher this, we'll just go get another USB 3 cable, random USB 3 cable, and use it instead. Yeah, Miles, that's what I aim to achieve around here. Create aneurysms in people that feel like you have to absolutely do it a certain way. And you know, I appreciate that. But there are times when you've got to just sort of work with what you got. Okay, this green is the one that actually needs the... My poor tip. Dipping it in toxic plastic waste like that. They're not really copper, these are dodgy wire, and it's actually often very difficult to solder this stuff. Okay, I hate it how it does that. So burn the sheath back, yeah, good on ya. Hot glue is going to become a necessity in this, I see. Okay, so what have they done here? They've twisted the two braids up. Yeah. This is probably a bit reminiscent for people of watching Lewis do Bafang stuff. I can hear all the PDSD phone lines going crazy now. People are like, oh, you wouldn't believe it what he did with the Bafang motor. It was a tragedy. Let's see if we can do a double header. Yes, double header. Yeah, going to lower solder iron temperature, that's annoying. There we go, we just go faster, that's what you do. You are correct though, the lower soldering iron temperature is the right way to do it. But right now my fingers are all sticky and I'm feeling annoyed, so I'm doing things the wrong way. Oops, chop the head off that one. Funnily enough, at this sort of scale, it's too big for the microscope, but too small for me without the microscope, you know what I mean. So I've got a bit of an awkward scenario where I need to be able to see what I'm doing, but the microscope just gives me too much of a close-up. And so I'm overshooting with a lot of what I'm trying to do. Can I just say how amazing it is, though, the manufacturers of cabling? Yeah, the people who make the machines that wrap up all this stuff, you know, sheath it, double sheath it, all that sort of thing. I mean, really, that's marvelous stuff. And then when you get like undersea telecommunication cable, it's got, you know, hundreds of cores, and yeah, I just find it amazing stuff. Anyway, enough of my sentimentality there. I guess I just sort of appreciate the engineering behind doing cabling. I mean, there's a lot of things in life where when you think about it, you go, what machine did they create in order to do this? I guess it appeals to my toolmaker side of personality. Yeah, after all, you know, producing things like Flexboard View and all the other software utilities I create. Yeah, there's the tool master in me. Started at school and... wait, that sounds very wrong. Anyway. That plastic sheath is annoying though. I've actually got to change gloves. They're covered in flux. What's this? Submarine fiber optic cables are drawn. Oh yeah. And all the stuff they put in there, like so that you got to have the power for the repeaters going through that cable to make sure the signal gets to the other end. And it is genuinely impressive stuff, and I don't think it gets recognized for what it is often enough, but that's reality. And then you get the crazy people that dig the cable up and tap into it, trying to steal a signal. I am kind of wondering the folly of my choice, whereas these are somewhat less flexible. I'll say we just go at it. Yeah, so we're going. Yeah, the original cabling job probably was okay, but because of the way that yeah, it wasn't reinforced with epoxy or hot glue even. You know, it would have been fine with hot glue. But because they didn't have that, then inevitably it was going to end up failing simply because of, yeah, just the natural flexing and everything. Okay, so that's USB 3 mostly connected. I've got to bring the braids together now to create the braidy bunch. Yeah, you can all hate me for that. I don't care. I don't care about the Brady Bunch anyway. I realise that's a bit of an ugly cluster, but we'll clean it up. I think. Maybe, maybe not. You can see the cables are already starting to get viciously ripped around, so hopefully we can complete this. Oh, son of a gun, they're all backwards compared to what I need them to be. That is so hilarious. Not really. Probably going to end up breaking half my wires on the USB 3 side now. Should have done them second. Idiot. Yow. Note to self: don't burn, don't burn your finger with the soldering iron, eh? Okay. Red, white. Come here, white. Come here, white. Why don't you be a right fielder? Right. Yeah, it's not the right way to do cables just then. Squishing it down like that, that's bad juju. Don't do that. I'm only doing it because it's mine. If it was a customer's, I would probably smack myself a little bit until it stopped being exciting and then do the job properly again. That is terrible. Well, the upside is we don't have any short going on there. I'm just going to bring that braid up in the back a bit. So we'll wash this and then we'll give it a Pharaoh's funeral, well, entombment rather, with hot glue. And let it be known that I'm giving myself a, well, that's a C minus at the best for that cabling. It's definitely would not give myself anything more than a C minus. It's passable, but it's bad. With regards to the hardness of hot glue sticks, yes, mine are extremely soft. I actually wish they were harder. But I haven't been able to source any reasonably priced hot glue sticks that have that extra hardness. Yeah, you're right. This is factory setting. This is factory style. So I get an A plus for factory style. If you want 5 volt on the hub connectors, you have to remove that diode. Seriously? Why is that? So let's see, that, okay, it looks like a common thing, and let me guess. Okay, so that takes that to there, and that's where we're losing our voltage. Probably about, yep, 0.6. I guess it's a protection thing to prevent flowback rather than them using a MOSFET configuration. They're just using a plain old diode. Oh, that is so shonky. Shonky. And instead they're using this connector here to get the full 5 volts in. Yeah, that's some beautifully shonky crap. I may have some shockety diodes, which will give us a lower forward voltage drop. Anyway, let us give this the hot glue treatment it needs. Yeah, that's probably about right. I reckon we can melt that down to form a nice ignite. Nice thing is we don't need a lot of hot air for this. I should probably do this while it's in the case, but well. think I need to give it more heat. Get a little more flow around the other side. Funnily enough, hot glue generally is fairly easy to get off, I find. It depends on how you sort of have stuck it on. If I went along and like really smushed this onto the surface, like really applied pressure, then yeah, you're right, it would actually be quite tricky to get it off. But if you let it so it just simply floats over the surface like this, then typically, yeah, you can just sort of pick it up from the edge and roll it off. Ah, G's and L's here. Oh man. So as you can see, we've got to do something similar on the other side. Ah, my great big... I had a great big doobie drip off. Yeah. I do love that with hot glue, you can just pick it up and... Let's see, I need another piece though. My clippers are too weak. We don't need quite the same size as the last one. This is just going to be more of a cap piece. Oop, straight through the board. But yeah, blah 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 blah, what am I trying to say? I've been looking for some good quality 11mm hot glue sticks. Because yeah, at the moment what I get when I order them is really very unpredictable. Then again, I suppose I have to accept there are limitations on the power that's available to me on my hot glue gun as well. Okay, we kind of want to push a little bit beyond these connectors. Now we've kind of achieved some pretty good liquidity there. More liquidity than Dogecoin. Let's give a chance for that middle section to cool down before I start pushing it back towards the end of the wire sheath itself. It's interesting, aside from the... whoa, whoa. I just lost all my balance then. Like vertigo major. As I say, aside from liking his fishing, about the only thing I know about my grandfather is that he was a glass blower. And this obviously reminds me of that. That was not good, losing my balance just then. I think I might have to retire because it's probably from tension in the back of the neck. But I think I'm going to have to. Nah, I doubt it's the glue fumes. I think it's just my posture. The temperature's way too low to be fuming. I'm just cooling off the hot glue now. Is that still on? Okay. That's coming out pretty good. And I think we'll just short that diode. Short that diode and get us our full... Hot glue is supposed to be used without solvent now. Oh, yeah. Now... what I will do is we'll remove the diode, but we'll put a polyfuse on it. So at least the polyfuse kind of gives us some protection, but without the loss of the voltage like this situation. Did you guys use a... Oh, for a moment then I thought they had used just a normal wire diode, but then I realised the body shape is definitely an SMC. Okay. Now I'll just go see what I've got in my fuses selection. Fuses. No, I wasn't actually, because I'm not even going to bother with the casing. Let's see, poly switch 3 amp. It's probably a bit bigger though. Yeah, they're a little bit big. Alright. Bridge it is. What is that? That's about a 1206, 1210 size resistor, that is. Let's see. Resistor 0 to, no, it's no. Greater than 10k. Ah, shunts. That'll do the trick. Well, this is not technically a 0 ohm resistor, but to be fair, a 0 ohm resistor is merely an what do you call it? This is probably a bit big. A 0 ohm resistor is just simply an unmeasured low ohm value resistor. As opposed to a shunt, which they've actually taken the time to measure. You mongrel, you're a little bit big. Damn you. Back in the box. So 2512's actually a little bit large. Fine, piece of wire it is. Yeah, I tried to do things nicely, but in the end it's a piece of wire. We'll use a couple of pieces of wire. It just feels so wrong. So incredibly, no, I can't do it. I can't do it. I can't use a piece of wire like that. Just wrong. It's terrible. Come on, resistors. Show me what you got. Geez, even a 1 ohm resistor is a better option. 30 ohm. Oh, great. Who the Fine, 1 ohm. No, 1 ohm at 3, no, that's not going to work either. I was going to say 1 ohm should be tolerable, but then I realised if I'm drawing 3 amps across that connection, that is going to be a nice 3 volt drop. This is really sucking. Wicked braid, yes, yes. Unmounted has the right idea. Wicked braid. This is what braid was invented for. Not for wicking, but rather for being supreme low ohm connections. Which is why you use it all the time in RF gear. Yeah, there we go. Yeah, 0 ohms. Thank you very much, Unmounted. Thank you for reminding me. There we go. Now that's a 0 ohm resistor that is hard to beat. Yeah, 100 amp fuse if you're lucky. Probably can go higher than that. That's come together quite nicely there, so that's good. Now the only downside is because I haven't got it. That's metal. Because I haven't got it protected or anything, we do have to make sure we don't have little pieces of metal lying around. It's not dodgy, man. It's resourceful. Okay. So now we got our 5 volts, so that's good. We're probably going to have to wait about 2 minutes or so, because that is probably, maybe even more, because we're going to have to wait for the OS to boot from there, and because we don't have keyboard or anything else connected, it has to essentially fail through to booting from that, and then it has to boot. And after all that, oh, here we go. 0 amps. That's funny, it's taking no amps at all now. What is going on there? Or is it still, it might still, I was going to say, it might still just be in the boot process. Still holding at 470. I could actually check the display with DisplayPort. Okay, DisplayPort HDMI. Which way is this? Right. You obviously won't be able to see this, but I will. Yeah, I don't know if it's going to transition though, because, oh yeah, there we go. Oh, we're still booting. And we just finished, we've got the login screen. Alright, it's interesting to note that this has not gone up from 4.7, so we'll plug it back in. We're holding steady at 1.5 amps. How does, what? Alright, okay, now we're all the way back to what we were trying to work out, and that is it the daughter board that is actually causing all the trouble? Is the daughter the one that is the troublemaker? Or the cable? Okay. So right now, we are holding 1.5 amps steady here, which says to me that that's fine. It could be that. And yeah, I probably should have plugged a keyboard and mouse in. Let me see what I can get. A mouse if nothing else. Oh man. There we go. I'm going to be really peeved if I find out that I was just the daughter board all along. It sounds about right to me. Shut down. Hey, if nothing else, we just learned a lot of other things tonight. Okay, so we're shut down. Let's plug the daughter board in and see if the nightmare begins. Okay, daughter board's in. Let me just check that you can actually still see everything. You can just see that. I don't really want to move anything on this desk, but no, the daughter board doesn't control the onboard port, but the daughter board shares the power line and the PM Sleep S4L line. So what we're trying to work out is whether we've got a problem in the flex, the daughter board, or whether it's not relevant. Yeah, it may be a case of, for some reason, because we're going through a hub, it's not going to do the bouncing anymore. I don't know. We've got to find out. Yeah, Franken Mac, and this is your primary display. So yeah. Hey, Luke Davis. Yeah, we're almost finished booting. Oh. Getting there. I was happy though that we fixed up that hub, because honestly, ever since I had that hub and I bought it, it was always problematic. Yeah, the charge is going up because it is running at the half amp at the moment. Grade 10 science project. It does look a bit like one of those sort of things, doesn't it? I really need like a mirror so you can see what's on the little display, or just get another little display. Oh, I didn't like that. It's glitching, interestingly. Interesting, this is still negotiated at 500 milliamps. Let's plug it in now. And it's holding 1.4. What the hell is going on? Oops. What is the USB controller on this machine? Please don't tell me it's the PCH. Because I'm now starting to think. There's no USB controller on this thing, is there? No, it's the PCH. Yeah, you're right, I should have booted into the... Alright, we'll try that again. Where's the key? I don't know where the keyboard for this one is. Oh, here we go. Let's see. Oh. It's kind of curious. Why didn't that come back up? it's complaining now. This is weird. It wants that battery. But why does it want it now? Why was it happy with it before? Was this while we're waiting for that? What's with web software and not like an apostrophes? Special character. Oh, you probably find a lot of the time they don't like them because you mean like when you submit forms and you have an apostrophe something in your form and it doesn't show up when you look back at your data. A lot of the time that's because when they're filtering like through PHP or whatever, they strip out things like that because that quote character can be used to escape data within a text string so that it becomes interpreted differently. And so you kind of have to, or like the other problem is it's probably SQL that's causing the problem actually. When they submit your data into the SQL database, the apostrophe is actually the terminator character for a string. My description. Oh, okay, I'll have a look at that. The only thing that diode did was just simply to stop voltage going back into it. That's about it. On the screen description you have. Oh, I see what you're saying. Right. Okay, yeah, I kind of know what's going on there. I think OBS doesn't like the text. Or what is it? Oh, I know. I think it's a URI encoded QR code that I use. And I don't think I... Great. Something's really up with this. Okay. So I'm plugging it in. To there. And then we're going to see what happens. It's doing it on this port. USB accessories disabled. Unplug the accessories using too much power. That's kind of weird. Is this actually a feature of the system? So the Mac is actually reporting on screen to me. USB accessory disabled. Unplug the accessory. It's using too much power to re-enable the device. It doesn't have to be the Delta board because maybe this board just is inherently limiting somehow. The reason why that confuses me though is that the threshold set on these power switches for the USB is 2.5 amp, and we're not drawing 2.5 amp. Yeah, even when we're on this side. Yeah, the daughter board, but you see, the trouble is it happens on both. The only reason why it's not happening on this right now is because it's going through a hub. And the hub, for whatever reason, is... I will say this. See, the hub is limiting it to 1.5 amps. So maybe there's something in the hub that actually sets that limit. So the hub controller chips don't allow for anything higher than 1.5 per port. You often see that on the okay, we are losing our 5 volts here. Okay, so we are draining a fair bit of current, so it is noticing it. But that is only on here. As soon as I remove this, it will be fine. Yes. So this is a real brain teaser. Okay, this is interesting. It's not squawking on that one. I took this out and it's not squawking. It's definitely squawking with the controller thingy in. 1.7. This is driving me... This is genuinely a weird fault. And see if that drops down a little bit. I'll just get another current meter. You're always annoying me. And of course now is the perfect time for me to not be able to find my alternate current meter. Oh, there it is. I hate these current meters. Everything's too flippin' small to read. Here we go. Interestingly, through this one, it only lets me have 1 amp. So it would seem that they're doing some sort of negotiation, isolating it from this here. But then that still brings up the question that 2 amps should not be enough to trigger these devices to actually go into the overcurrent mode. Okay, I'm just gonna have to switch. Just hang on there. I can't see. because the screen. Oh, you can't really read it. Just trust me. I'm saying it's reading 1 amp of charge rate on that, and that's through this particular unit. Whereas this unit, plug it in, and it'll give us 1.5 amps, and still okay. But it would seem that the current limit is defined by whatever your device connection is. Like in this case, no, that doesn't make sense because that will let me get up to, oh, I know. The hub has a 1.5 amp per port limit, I suspect, and that is as maximum as that's going to get. We can find this out by looking up this hub and seeing if that is the case. Oh, for fuck's sake. I mean, useless piece of junk. Well, I'm just going to check anyway. No, it's only 1:30. We're cool. Yeah, look, I really can't make heads and tails of this. I'm on their website now, just looking at. Yeah, kind of curious. So I don't know. I just don't understand what's going on. I mean, is the board being oversensitive? But what I can't understand is that I changed the threshold, the because you can program the threshold that the chip will actually kick out, and I changed that to be 4 or 5 amps, and it still kicked out. So it didn't make any sense to me. And I think what's happened now is that the phone has enough charge in it that it's no longer going at a rate that will cause this to trip. Okay, we're at 1.6 amp constant. Does have, it can, yes, you can, there's the USB-C here, mini USB that you can put probably 2 or 3 amps into it. Do I have another daughter board? I might have somewhere. I probably should have actually, but not right now. And I think I'm probably going to have to, like, time out here because I think I'm definitely going around in circles. We've got something going on, but we haven't nailed it down. I do think that we may have done a bunch of work on the board that we perhaps don't even need to do. So switch over to the other input. Prolux, in this particular case, the PCH listens for the overcurrent signal from the device. I'll show it on the schematic just now. Just give me a second here. I'm shutting down. Okay, we go to the schematic. And we go to the port. Okay, this chip here, this U4600, just little 8-10 pin chip or whatever it is. Okay, it is the one that does the current limiting. And what will happen is, if you exceed that current limit, it will pull this fault line down. So when the fault line gets pulled down, that's when it goes, this line here, it goes to the PCH. And you can see it's an input, and it's going in to the PCH. And then there's also the one for the other one. So it's got two inputs for overcurrent detection, but those lines are managed externally by this chip here. But yeah, like I said, I've set this 4601, 4600 to a value where it should be 4 amps. These switches are capable of up to, I think, 5 amps. And it still trips, so it drives me absolutely mad. I have replaced the chip, I have replaced the sense resistors, I have replaced the capacitors. Knowing now that Mac OS actually detects the overcurrent line being tripped, then that just makes it all the more confusing for me. The only way that I could see this false tripping is if the input supply dived down, but even then that doesn't make a lot of sense. No. So I don't know, I'm genuinely stumped by this one. I'm getting a lot of almost here type hints, but overall I'm still stumped. So I think what we'll do is tomorrow I'll go find another daughter board. Let's go to the overhead. Yeah, tomorrow I'll get another daughter board. We'll try that. And fingers crossed, in all honesty, at this point, I'll be much happier if it's just the daughter board and I just change that over. Because, yeah, this has been one of those maddening type faults that seem simple, should have been solved in 10 minutes, but somehow it's turned into a great big fiasco. SMC, again, it shouldn't come into play because those chips are the only chips that do the current sense. And we know it must be something to do with current sense or some sort of voltage drop, because we can sit at 1.6 amps and it still doesn't trip. We go to 2 amps and it trips. So yeah, anyway. Alright, well, yeah, we'll tackle it tomorrow. Thanks everyone for being here. I'm sorry we didn't really get a huge win, but we had fun, you know. We got to stuff around with this and find out why this has been dodgy ever since I bought it. I don't think I will put it back into its metal case. I don't think it's do you fit in there still? If I pushed you the wrong way. I mean, that could maybe work if I fill it up with hot glue. At least it will stop it from shorting things out. Anyway, we had fun finding out why that was dead. And not much else. So, alright, you all take care. I'll see you next time. Catch you later.